Swayam Prabha. Digital India. Educated India.
Welcome to the sixth lecture of the lecture series, which is on tutorials on design of transmission elements. Till this lecture, we studied about the problems related to the spur gear, helical gear and bevel gear. Now, this lecture is related to basics and force analysis of worm and worm gear. We know that these worm and worm gears are the transmission elements which are used to transmit power between shafts which are non-parallel and non-intersecting. The worm gears are used for transmitting power between two non-parallel and non-intersecting shafts. High gear ratios of 100:1 can be achieved with the help of a single pair of worm and worm gear. This is a worm and its axis of rotation is shown by this central line, and the worm is meshed with a gear which have axis of rotation given by this one. And so the axes are non-parallel and non-intersecting. And this worm is just like a screwed element. And so whatever the properties of a screwed element has, the same will be for the case of this worm. And the gear which is meshed with it will have a curved type of top land, so that the curved worm and the gear has maximum contact area. Similarly, this worm may have a enveloping type of thing like this. So, if both have a curved type of thing which is called the enveloping, then it is called the double enveloping, but if only one has, then it is a single enveloping. This figure shows clearly about the axis of the worm and the axis of the gear. Now, let us study in brief the different nomenclatures which are used in the worm and worm gear. This is a worm, and distance between two consecutive points is called the axial pitch px, and the number of there will be number of start on the worm similar to the screwed element. If number of start or the screw which is going all over its length is 1, then it will be called a single start worm, otherwise it will be multiple start. So, this is the gear which is meshed with the worm, and it is shown in the side view. This is the pitch cylinder of the worm, and the gear teeth of the worm will be inclined with the axis, and that angle which it makes with the normal to the axis, this angle is called the lead angle. This angle is the lead angle, and the distance moved by a particular point when one complete rotation is given to the worm is called the lead, and lead is equal to number of start on the worm which is equal to number of thread on the worm multiplied by axial pitch. So, lead is equal to Px multiplied by Zw, where Zw is the number of start or the number of thread, number of teeth on the worm. And similar to the power screw, there will be a lead angle. That means when the thread is, if this thread is unwound, then the length of thread will be this one. This is the lead, the distance moved. Then the angle, this angle is called the lead angle, and the tan of the lead angle lambda is equal to the lead L divided by pi dw. In the case of power screw, this was pi dm, the mean diameter. This will become pi dm, pi dw, where dw is the pitch cylinder diameter of the worm. So, lead angle, tan of the lead angle is L divided by pi dw. Now, this angle, the angle made by a line which is tangent to the screw and axis of the worm is called the helix angle of the worm. Now, there is one relationship which is very important for the case of worm and worm gear is, for 90 degree for this shaft angle, we have axial pitch Px is equal to the circular pitch of the gear. So, circular pitch of the gear P, you may say C or simply P only, which is equal to pi multiplied by module of the gear, and the same will be for the case of worm also. So, this is also equal to axial pitch of the worm Px. The enveloping gear is shown here, curve type of structure. Here the same, the 3 start worm is shown here, and so the lead will equal to 3 times this axial pitch. Axial pitch is this distance. This is the pitch cylinder of the worm, and 3 times axial pitch is equal to lead, and this is the thread length of 1 revolution. And so, the angle between tangent to the thread and normal to the axis of the worm is called the lead angle, and this is equal to tan lambda is equal to L divided by pi dw. In this figure, the pitch circle diameter of the gear is shown, and the pitch cylinder diameter of the worm is shown, and this pitch circle diameter is actually the diameter of the pitch cylinder. Now, let us take a problem which is give you some idea how to get the parameters of the worm and worm gear and the force analysis. A two tooth means two tooth right hand worm. It means number of start on the worm is 2, and so Zw is equal to 2. Right hand worm, similar to the screw, the worm will be right hand or the left hand. Usually it is of right hand. Similar to the nut and bolt analogy, we will know with the rotation of this worm what would be the rotation of the gear, knowing whether the thread on the worm is right hand or the left hand. Now, the worm is rotating at 20 revolution per second to a 30 tooth worm gear. It means number of thread on the gear Zg is equal to 30. The gear has transverse module of 4 mm. The module of this gear system is 4 mm and a face width of 60 mm. The gear has 60 mm face width. It means the face width, this length of the gear is 60 mm. The worm has a pitch diameter of 50 mm. If this is the pitch cylinder of the worm, then the diameter of the pitch cylinder dW is 50 mm. And the face width of the worm is 60 mm and the face width will be this one. The normal pressure angle is 14.5 degree. This is the angle through which the force will transmit from driving gear to the driven gear, and it will act along the line of action. The material and quality of the gearing to be used are such that curve B of the coefficient of friction should be used to obtain the coefficient of friction. So, to get the coefficient of friction, we will use curve B. Why we are going for coefficient of friction? Because in the worm and worm gear, the motion is pure sliding, and so there will be appreciable amount of friction. There will be loss of power due to large sliding velocity. So, in the case of worm and worm gear, we have to find the loss of power due to friction, and so we need the coefficient of friction. Now, we have to find the axial pitch of the worm, the center distance. Center distance is, this is the pitch cylinder of the worm and this is the axis of rotation of the worm, and this is the center of rotation of the gear. Then the distance between axis of rotation of the worm and the axis of the gear is called the center distance. This we have to find, and the axial pitch is this one, distance between the two consecutive points of a thread is your axial pitch, Px. So, this we have to find. Then the lead is for the double start worm, the lead will be distance between two consecutive threads, and so it will be this one. This will be your lead. And the lead angle, tan of the lead angle lambda is equal to L divided by pi dW, where dW is the pitch cylinder diameter of the worm. B part of the question is, in this figure, is the drawing of the worm gear oriented with respect to the coordinate system described in this diagram. This is your y axis, this is x axis, z axis, and this one is the x axis. This is the pitch cylinder of the worm, and this is the pitch cylinder of the gear. Now, we have to find the forces exerted by bearings against the worm gear shaft. The shaft of the gear, this is the axis of rotation of the gear and this is the axis of rotation of the worm. So, the shaft of the gear is supported by two bearings, bearing A and bearing B. So, we have to find the forces exerted by the bearings against the worm gear shaft and the output torque. So, the torque which will be on the gear shaft. Now, the given in this problem are ZW is given as 2, number of start on the worm is 2 and it is right hand. Power which used to be transmitted is 0.75. number of revolution of the worm is 20 rps, revolution per second. Number of teeth on the gear is 30. Then the module is 4 mm. Face width of the gear is 25 mm. Pitch circle diameter of the worm is 50 mm. And the face width of the worm FW is 60 mm. And the pressure angle is 14.5 degree. Coefficient of friction, curve B, has to be used. Now, let us find the axial pitch of the worm. Now, we know that axial pitch of the worm is same as the transverse circular pitch of the gear. And if module is m for the gear, then circular pitch, this transverse circular pitch is given by pi multiplied by mt. So, this will also be equal to the axial pitch of the worm. So, axial pitch of the worm is circular pitch of the gear, and that is pi multiplied by module, the transverse module, and that is equal to pi multiplied by 4 because module is given as 4 mm, and so axial pitch is 12.566. Now, the pitch diameter of the gear. Now, module and the number of teeth on the gear is given, and so knowing that module is equal to the pitch circle diameter d divided by number of teeth on the gear, we can find the pitch circle diameter. So, that is number of teeth on the gear multiplied by module is 120 mm, and that is the pitch circle diameter of the gear. Now, knowing the pitch cylinder diameter of the worm dw, which is given, and determined dg, this dg of the gear, we can find the center distance, which is equal to dp plus dg divided by 2. The center distance is this one, and this is half of the dw plus dg, and it comes as 5 mm. The lead is number of start or the number of thread on the worm multiplied by axial pitch. Axial pitch is 12.566 multiplied by 2 is the number of thread on the worm, and so the lead is 25.132, and that will be related to these two threads, 1 and 2. So, this will be the lead for the double threaded worm. Then the lead angle is given by, this is your lead angle. So, this distance is pi dw, and this is your lead, and so tan of the lambda is given by lambda is tan inverse L divided by pi dw, and it comes as 9.09 degree. Then the pitch diameter of the worm is not a function of its number of threads ZW. That means the relationship which we were having for spur gear, helical gear and bevel gear, that dg, pitch circle diameter of the gear, pitch circle diameter of the gear divided by pitch circle diameter of the pinion is equal to number of teeth on the gear divided by number of teeth on the pinion. This relationship is not valid for the case of worm and worm gear, and this means that the velocity ratio of the worm gear set is determined by the ratio of gear teeth to worm threads. It is not equal to ratio of gear and worm diameter. And so, knowing the revolution of the worm, that means NW, we can find what will be the revolution of the gear, knowing the number of threads ZW on the worm and number of threads on the gear ZG. They will not be related, these will not be related with the pitch diameters. So, the speed of the gear can be found from this relation, that ng divided by number of revolution of the gear divided by number of revolution of the worm is equal to number of revolution of the worm divided by number of teeth on the worm divided by number of teeth on the gear. Number of teeth on the worm is 2 and number of teeth on the gear is 30. It is given in the problem, and so the ng is equal to 1.33 rps. You see, appreciable amount of reduction is achieved. The pitch line velocity of worm is, knowing the pitch cylinder diameter of the worm and the revolution of the worm, we can find the pitch line velocity, and that is given by pi dw nw divided by 1000. dw is in mm and nw in is rps, revolution per second. Substituting the values, we got Vw, the pitch line velocity of the worm, is equal to 3.14. The sliding motion in worm gear set. In our study of spur gear teeth, we have learned that the motion of one tooth relative to the mating tooth is primarily a rolling motion. In fact, when contact occurs at the pitch point, the motion is pure rolling. That means, in the case of pinion and gear, when the contact was at the pitch point, then the motion was pure rolling, and as contact was moving away from the pitch point, the motion was a combination of rolling and sliding, and the sliding motion was proportional to the distance by which the point of contact was away from the pitch point, and at the pitch point it was pure rolling. But in the case of worm and worm gear, the relative motion between worm and worm gear teeth is pure sliding, and so we must expect that friction plays an important role in the performance of the worm gearing. Therefore, the pitch line velocity of the gear is equal to Vg is equal to pi dg, pitch circle diameter of the gear, and the revolution of the gear divided by 1000. dg is 120 mm and the revolution of the gear is obtained as 1.33 revolution per second, and so Vw is 0.503. You see, there is a difference between the pitch line velocity of the gear and pitch line velocity of the worm. Pitch line velocity of the gear is only 0.53. It means there is a sliding motion, and the sliding motion can be found as, or the sliding velocity can be found from this diagram, where we have a pitch cylinder of the gear shown here, and its axis of rotation is this one. This is the gear axis, and the worm is shown by this dashed line, and the worm is above the gear. Now, the pitch line velocity of the worm will be in the direction of its transmitted force. Transmitted force will be Wt. The direction in which the transmitted load on the worm will act, and pitch line velocity of the gear will be in the direction of the transmitted force on the gear, that means Wgt. And the sliding velocity or the sliding motion will be along tangent to the thread. This is the thread on the worm. So, tangent to the thread will be the sliding velocity, okay. And from here, and you see the angle between tangent to the thread and a line normal to the axis of rotation of the worm. Axis of rotation of the worm is this one, and so this angle is the lead angle. So, we can find a relationship between the pitch line velocity of the worm, pitch line velocity of the gear, and the sliding velocity, and that is given by Vs is equal to Vw divided by cos of the lambda. Substituting the value of Vw and cos of the lambda, we got sliding velocity as 3.14 meter per second. Now, knowing the pitch line velocity of the worm, now we can find what will be the transmitted force. the transmitted force by the worm is given by h, the power which is to be transmitted, divided by pitch line velocity of the worm. Power which is to be transmitted is 0.75 kilowatt divided by pitch line velocity of the worm provides us the transmitted force by the worm is equal to 0.2389 kilonewton. Okay. As pinion is rotating in anti-clockwise direction, you see this is the axis of rotation of the worm, and the direction by which it is rotating is shown by this arrow. Okay. And this is a driving member. And so, the transmitted load on this driving member will be in the direction opposite to its direction of rotation. So, at the point of contact, at the point where these two are in contact, the pitch cylinders, that will be called the pitch point. At that pitch point, the motion of the worm is in this way towards the positive x axis, and so the transmitted load on the worm will act in the negative direction of the x in this way. This should be the direction of WWT, the transmitted load on the worm. Let us see. This is the direction of rotation of the worm, and so the tangential force on the worm will act opposite to its direction of rotation, and that is shown here. And this force, the transmitted load on the worm is acting in the direction of x. It is negative x, but parallel to the x. And so, it may also be called Wx, because this transmitted force we have obtained by considering frictional force equal to 0. We have not considered yet the frictional force. Okay. So, this WWT is the force acting in the direction of x on the worm. Wx for worm will act in the negative x direction. Now, the sliding velocity Vs is determined as 3.18 meter per second. It is given to use curve B of the coefficient of friction. Coefficient of friction curve is given here. On the x axis is the sliding velocity, on the y axis is the coefficient of friction, and two curves are there, curve A and curve B. And in our problem, it is given that the system is in such a way that we have to use curve B to get the coefficient of friction. Now, as per the sliding velocity, which is 3.18, so 3 will be somewhere here and 18, so somewhere here. So, corresponding to that, we will get the value of our coefficient of friction F, and it is 0.03. Now, knowing the coefficient of friction, now we can find what will be the force acting on the worm and worm gear system when friction will be there. In this diagram, the forces which will act on the worm are given when it will transmit power to a gear. This infinitesimally small element A, B, C, D, then E, F, G, H is there, and the normal load which will act along the line of action is from H to C. This is the Wn, and this Wn will have component in the axial direction of the worm. This is the axial direction. So, GF is the axial direction, or DC is the axial direction, BC is the radial direction, and tangential direction is C to F. So, when we will take the component of this Wn in the direction of y, which is the radial direction, in the direction of x, which is the tangential direction, and in the direction of z, which is the axial direction, we will get the forces which will act at the pitch point when there will not be friction. And the angle between HC and GC is normal pressure angle. And the angle DCG is the lead angle. So, knowing these angles, we can find the component of forces without considering the friction in the direction of x, y, z. Now, we know that the frictional force will act along the thread, and the thread is making an angle lambda with a line normal to the axis of rotation of the worm, and the axis of rotation of the worm is this one, which is parallel to the z axis. So, the frictional force which will act along the thread shown by this yellow color arrow is Fwn, the frictional force Fwn. So, along this line Ci, Fwn is acting, and the angle between I, C and this x is lambda, the lead angle. And so, we can find the component of frictional force in the direction of x and in the direction of z, and they will be added to the component of Wn in the direction of z and in the direction of x. So, the total force acting in the direction of x is WWT is given by Wn cos phi n sin lambda plus F cos lambda, and the component of force which will act in the direction of y, which is the radial direction. This is the radial direction of worm, not gear, of worm, and this is the tangential direction, and the Wz is the axial direction of the worm. The equation is Wn cos phi n sin lambda plus F cos lambda. And so, the normal force Wn, this one, is equal to Wx, the force acting in the direction of x, divided by cos phi n sin lambda plus F cos lambda. Now, knowing the component of force acting in the direction of x, which we determined previously, WWT, Wx is 235 Newton, and so Wn is given by 1287.1 Newton. Now, with the coefficient of friction F is equal to 0.03, we will find the other components. The Wy is equal to Wn sin lambda, it comes as 332.23 Newton, and Wz force in the direction of axis of rotation of the worm is given by this one. Here we have taken consideration of the coefficient of friction, and so the force acting in the direction of z is 1244.8 Newton. So, at the pitch point, we determine the forces which will act in the direction of x, y and z of the worm, where x is the tangential direction, y is the radial direction and z is the axial direction of the worm. Now, let us find the direction of component of forces acting on the worm. We have found the magnitudes, but let us find the direction in which they will act. So, the axial force WA, you see, along the, this is the z direction, the axis of rotation of the worm, and the Wz which is acting is 1244.8 Newton. Now, the direction of this WA is determined from the right hand rule, because we know that, and it is given in our problem, that the thread on the worm is right hand. And so, we will apply the right hand rule. We will take our right hand and these fingers except the thumb will be folded in the direction of rotation of the worm. And when we are viewing it from the positive z axis, then the direction of rotation of the worm is in the anti-clockwise direction, the direction shown here. Okay. So, the thumb will give you the direction of axial force. So, if along the z axis we are making our hand in this way, then this direction, this arrow is giving the direction of axial force, and this is the direction of positive z axis. It means WWA, the axial force on the worm, will act in the positive z direction. Well, this one, it will act in the positive z direction, it is WZ. And the radial force, WWR. We know that radial force always acts along the axis of rotation. So, axis of rotation towards this one, it means along the positive y direction, this WWR will act, and that is the positive y direction, it is shown here. And the tangential force will act opposite to the direction of rotation, and so it will be in the negative x direction. So, we got the direction of all the force components on the worm. Now, we identify the components of forces acting on the gear and their direction. If we see the worm in this figure and gear in this figure, then the x direction of the worm, what is the x direction? This is the x direction on the worm, and this is the tangential direction of the worm. This is tangential direction. But for the case of gear, the x-axis, this x-axis is the axial direction. So, whatever force was acting on the worm in the x direction, the force will become the axial force on the gear. And so, WT, the force acting on the worm in this way, was the tangential force WT, it will become the axial force on the gear. See this one. This is your Wx on the worm for the case of worm. Opposite to this, a reaction will act on the gear, and that reaction is in the x direction. This is just, they will be equal. They will be equal, but opposite in direction. And so, WWT, this is your WT, tangential force on the worm, will become minus of the axial force on the gear. Then, along the y direction, the y direction for the worm is the radial direction, and the same is for the case of gear. It means your the force which is acting on the worm in the y direction is WWR. Opposite to this force will be the reaction on the gear, which is shown here, and this will be, this is again the radial direction for the case of gear, and so it will be WGR. Their direction are opposite, and so we will say that WWR is equal to minus of the WGR. Now, let us see the z direction. Z direction for the worm is axial direction. About the z axis, this worm is rotating. So, z axis or the z direction is the axial direction of the worm, and let us see what will be the z direction for the case of gear. The force which will act along the z direction will be the tangential direction. If a line is drawn on the pitch cylinder along the z, it will be tangent, and so it is the tangential direction. So, z is the tangential direction. It means whatever force was acting in the worm in the z direction, the reactionary force which will act in the direction of z will become the tangential force. So, it means WA is equal to minus of the WGT, and which is given here. So, we have determined the direction of tangential force on the gear. Knowing the direction of tangential force on the gear, we can find the direction of rotation of the gear. We know that this gear is a driven member and worm was the driving member. And therefore, the direction of tangential force on the gear will be in the direction of rotation of the gear. And so, the direction of rotation of the gear should be as per the arrow shown by in this figure. And in the direction of rotation, this WGT will be acting. It means when we will see the gear from the positive x-axis, it is rotating in the clockwise direction. So, by this way, we determine the direction of rotation of the gear. So, it is clockwise direction when viewed from the positive x-axis. These all forces are shown in this figure again by just rotating this system in the plane of zx a 90 degree. That means about y-axis this system is rotated 90 degree and we got this figure. This is the worm, axis of rotation is z and the tangential force is acting in the direction of x, radial force in the direction of y and the axial force in the direction of z. And the reaction of these forces on the gear are the axial force on the gear, radial force on the gear and tangential force on the gear. This is the direction of rotation of the worm. We now identify the components of these are the forces which are acting on the gear, WGA, WGR and WGT. So, at this G point, we have identified the forces which will act on the pitch cylinder of the gear and their direction is also determined. With this, let us draw the free body diagram of the shaft of the gear. Shaft of the gear is drawn here in the isometric view. The axis is, this one is x, this is y and this is z. This is gear A, bearing A. Bearing A is shown here. Bearing A is shown here and bearing B, which is at this location, is shown here. And from this axis of rotation of gear, at a distance of dg divided by 2 in the direction of y is the pitch point G, this G, and the distance is, this distance is dg pitch circle diameter of the gear divided by 2. That is shown here. Pitch circle diameter of the gear is 120 mm. So, distance of this and this pitch point will be dg divided by 2 means 60. So, that is shown here. Okay. This G and this x-axis. From x-axis the distance of G is 60 and this is shown here 60 and this point you may say this as A, B, C. So, this is your C point. So, distance AC is 35, this distance is 35. AC is 35, CB is 60 and CG is 60. And at the pitch point G, the forces acting on the gear are WGR along the direction of negative y, the axial force in the direction of positive x and the tangential force in the negative direction of the z. Now, with this diagram, we will apply the static equilibrium equations to determine the unknown bearing reactions. The bearing B is to be take the thrust load and so it has 3 component of forces in the direction of z, in the direction of x and in the direction of y. Bearing A should not take the thrust load and so it has no any reactionary component in the direction of x, it has component in the direction of z and y. And the torque which is to be transmitted by the shaft of the gear is T. So, let us find. We shall make B a thrust bearing. Then we if we see this figure, free body diagram, then we know that, and we found that in the direction of x only two forces are acting. The WGA is acting in the x direction and FBX is acting in the x direction. And so, summation of forces in the direction of y is equal to 0 makes FBX is equal to 235, the WGA. This is WGA. Similarly, taking moment about z axis, the moment provide us the FBY. FBY is equal to 266.08 Newton. Then taking moment about y axis. About y axis, again moment is taken and then it is given as 1244. 1244 is the WGT, and it is trying to rotate the y axis with force WGT multiplied by this distance 35, and the direction of rotation is in this way. And the next force which is trying to rotate the y axis is this FBZ. So, FBZ multiplied by this distance AB, this is C, AB is 35 plus 60 is equal to 0, and from this we got the value of FBZ. Now, summing forces in the y direction. In the y direction, the forces which are acting are this WGR is acting in the y direction, this FAY is acting in y direction, and FBY is acting in y direction. These two forces are acting in the positive y and this is acting in the negative y. And so, minus of the 322, then plus FAY and FBY. FBY we have just determined, which is 266.08. So, plus FAY is equal to 0. That means summation of all forces in the direction of y should be 0. It provides us the FAY is equal to 56.15 Newton. Now, summing the forces in the direction of z, that means summation of all forces in the direction of z should equal to 0. Now, in the direction of z, the forces which are acting are the FAZ, then FBZ and this WGT. And so, when we added it, we got the FAZ, and this is equal to 786.2 Newton. Now, we still have one more equation to write, summing moment about x-axis. Moment about x-axis provides us the torque. That means, the tangential force is your 1244 and it is trying to rotate the x-axis by an amount equal to WGT and distance GC. Okay. So, 1244.8 Newton multiplied by this GC distance 60, and this is trying to rotate in this way. So, we are viewing from the x-axis, then in the clockwise direction, and so the reactionary torque will be in the anti-clockwise direction, and from that we got the torque which will be transmitted by the shaft of the gear is 74.68 Newton meter. It is because of the frictional loss that this output torque is less than the product of the gear ratio and the input torque. So, after studying the force analysis and knowing the basics of the worm and worm gear, now we are going to just study the steps which will be used in the designing of a worm gear mesh. Now, a usable decision set for a worm gear mesh includes the function which we want to perform with the help of worm and worm gear. That means, the power which we want to transmit with the speed. What will be the speed of means number of revolution of the worm and number of revolution of the gear, and so the velocity ratio mg. Mg will not be in the ratio of pitch diameter of the gear to pitch diameter of the worm. It will be in the ratio of z on the gear divided by z of the worm. Then mg, then this Ka, application factor, depending on the application in which we are going to use this worm and worm gear set. Then the factor of safety Nd. Then the tooth system. In the tooth system, we have to find the axial pitch of the worm, then the module and other systems. Then the material and processes of the worm and worm gear, the number of threads on the worm Zw, axial pitch of the worm Px, pitch diameter of the worm Dw, then the face width of the gear and lateral area of the case. That means this gear, this worm and worm gear will be kept in a casing, and that casing will have some lateral area, and as we know that in the case of worm and worm gear there is pure sliding motion and there will be frictional losses, and due to that frictional losses heat will be generated, and that heat should be dissipated so that the lubricant which is there should not lose its lubricating property. And so we must know the lateral area of the casing and through which what amount of heat is lost, and the heat which is generated should be transferred so that there should be a balance. So we must know also the lateral area of the case. The methodology is design decision is the axial pitch of the worm. In the previous cases, we were starting with the module of the gear, but here the axial pitch is an important parameter, and we will start with a trial axial pitch. Since acceptable proportions are implied in terms of center to center distance, which is not yet known, one choose a trial axial pitch. Having Zw and a trial worm diameter Dw, we get the number of teeth on the gear required is equal to the velocity ratio multiplied by number of start or the number of thread, number of teeth on the worm, and the module is equal to axial pitch divided by pi, because we know that axial pitch Px is equal to the circular pitch of the gear, that is pi multiplied by module, transverse module Mt. Okay. So, we can find the module which is required, which is equal to Px divided by pi, and knowing the module we can find the pitch circle diameter of the gear, that means Zd multiplied by the transverse module. Then we have a relationship which says that the pitch diameter of the worm should be in the range of this one. The lower value of pitch circle diameter of the worm or the pitch cylinder of the worm is there, and it has diameter equal to dw, and this dw provides us the center distance also. We know this is the worm, this is gear, center rotation of the gear is this one, and this distance is equal to dg, and center to center distance is c, and we know that c is equal to dg plus dw divided by 2. Now, the d is this dw, the diameter of the worm is a function of center distance, and center distance is a function of dw. So, how to get the matching terms? That means the dw lower is given by this value and the dw higher is given by this one, and the dw should be greater than or equal to the lower value of dw and less than or equal to the higher value of dW. So, what we can do is, first of all, we select the Px. From this Px, we get the module, and from the module, we have this dg, and then we will get a value of dW, and we will find the center distance c. This is a first trial center distance c based on our trial dW, and we will see that the center distance which we are getting is providing the dW within this range or not. If this is not, then we will again choose a new value of dW which is in the within the range of dW lower and dW higher. Then it will be the second value of dW. From this second value of dW, substituting here, we will get the second value of c. Then this c will be again used to get the lower value of dW and the higher value of dW, and then we will choose the third value of dW which will be within that range, and then that dW will be substituted here to get the value of c. And this process is repeated till the two consecutive center distances are almost same. Then that dW is taken as the final dW, and we will move to get other parameters. So, that is shown here. Now, worm gear analysis. Compared to other gearing systems, worm gear meshes have a much lower mechanical efficiency due to sliding velocity and loss of friction. Okay. Cooling for the benefit of the lubricant becomes a design constraint, sometimes resulting in what appears to be an oversized gear case in light of its contents. If the heat can be dissipated by natural cooling or simply with a fan on the worm shaft, simplicity persists. Water coils within the gear case or lubricant out pumping to an external cooler is an next level of complexity. For this reason, gear case area is a design decision for the case of worm and worm gear. So, with this we are ending this basics and force analysis tutorial on the worm and worm gear. In this particular tutorial, we studied the brief about the worm and worm gear parameters, like the axial pitch, its number of thread on the worm, and pitch cylinder diameter of the worm, and the pitch cylinder diameter of the gear, and the center distance. And we found that the axial pitch of the worm is equal to the circular pitch of the gear for the case when the shaft angle is 90 degree. And thereafter we determined the forces which acts on the pitch point of the worm and worm gear, and thereafter we found the reaction on the bearing with the help of applying static equilibrium equations. Thank you.